Today we're going to take a quick look at a couple terms related to coordinate geometry. Now what coordinate geometry means is it's where we're investigating geometric figures that are on a coordinate plane. And remember, a coordinate plane is just our x and y axis, right? So the first term that we're going to look at is called the midpoint of a segment. A midpoint of a segment is a point that divides the segment into two congruent segments. So if I have segment PQ here that's on the xy axis, point M would be considered the midpoint of this segment. And it's the midpoint because it would be in a place so that segment PM would be congruent to segment MQ. So they would have the same length. Now, one way to figure out where the midpoint is you use this formula right here, which looks confusing, but all it is that you're averaging the x coordinates and the y coordinates. So for instance, it says here that we're going to take x1 plus x2 and divide by 2. Well, x1 and x2 are just our two x coordinates for the endpoints of our segment. So in this case, we would be taking -4, the x coordinate of P, plus 2, the x coordinate of Q, and then we would be dividing that by 2. And so that's going to be the x coordinate of our midpoint. Now if we think about -4 plus 2, that's going to be -2, and then -2 divided by 2 is going to give us -1. And you can see that's where this -1 comes from in the midpoint's x coordinate. Now for the y coordinates, we're going to do the same thing. We're going to take the -3 for the y coordinate of P, and we're going to add it to 1, which is the y coordinate of the other endpoint, and we're going to divide by 2. So that is -3 plus 1 would give us -2 again, and -2 divided by 2 is going to give us -1 again. So that's where our midpoint is, -1, -1. Perhaps another more intuitive way of figuring out where the end or the midpoint would be is to think about walking from P to Q. Of course, the most direct way to walk there would be along the actual segment, but another way you could get from P to Q is to go straight right and then straight up along these dotted lines that we see down here. Or you could go up and then right. But in any case, let's think about if we were going straight to the right, but we only wanted to get halfway from P to Q. Well, in that case, what we would do is we would walk half the distance from P to Q. Now, it looks like that's 6 blocks, but if I look at the scale of this graph, each block is actually worth half a unit. So walking from P to halfway over would be walking a total of 6 blocks, which is 3 units. And then if I walk up halfway from where I would need to go from this point up to there, that's 4 blocks, which is a total of 2 units. And so now if I go from -4 and I go 3 units in the positive direction, I end up at -1. And if I go from -3 up 2 units, I end up at -1. So that's another way, maybe a more intuitive way to think about why -1, -1 would make sense as the midpoint between these two endpoints of the segment. Let's take a look at another example real quick here. Let me just scroll down. So here we have another example that says, what is the midpoint of segment AB? I would encourage you to pause the video now and try and work this out on your own. Okay, let's take a look at that. So we have an x coordinate here and a y coordinate here. So we'll call those x1, oops, that should be y1, x1 and y1. And then we have a second x coordinate and a second y coordinate here. So we can call that x2 and y2. To find our midpoint, remember we're going to add the two x coordinates together, divide by 2, and we're going to add the two y coordinates together and divide by 2. So for this problem, we would be taking the -3 for x1 plus the 4 for x2, and then dividing that by 2. That's going to be the x coordinate of our midpoint. And then for the y coordinates, we're going to be taking 2 plus -2 and dividing by 2. And there's our y coordinate for the midpoint. So our midpoint will now be at, see, -3 plus 4 is +1. And 1 divided by 2 is just going to stay as 1/2. 2 plus -2 gives us 0. And now 0 divided by 2 is going to give us 0. So our midpoint is at 1/2, 0. And I always like to, at the end of a problem like this, I look at my answer, I look at the picture, and I say, does that make sense? So a midpoint of 1/2 comma 0 would mean start at the origin, go to the right half a unit, and then don't go up or down. That's what the 0 would mean. So that would put us at about right here. And that does seem to make sense. It looks, just eyeballing this picture, it looks like segment AM and segment MP are congruent. Now we can use this same idea of how we'd find something that's halfway between 2 points to find something that's another kind of fraction of the way from one point to another. We call this partitioning a segment. So if we were looking for the point that is 3/5 of the way from A to B, here's how we're going to do it. Now 3/5 means it's a little bit more than half, right? Because 3/5 is like 0.6 or 60%. So we're going to go 60% of the way from A to B. So starting at A, try and get a little over halfway to B. And where would that point be? That's exactly 3/5 of the way. Well, what we're going to do here is we're going to find the distance from, we're going to find the x distance, like how much we have to move in the x direction and how much we have to move in the y direction. So kind of thinking about this horizontal movement, how much horizontal movement and vertical movement do we have to make? So in other words, we're kind of looking at these dotted lines that would be moving straight horizontal and straight vertical. And we're going to take 3/5 of this distance and 3/5 of this distance and add those amounts to the x and the y coordinates. Now that might sound a little confusing, me just talking through it, so let's take a look at how we're going to do this. So I like to break this down and say, okay, what is my horizontal distance from A going to B? So I would be going from the coordinate of 3 to the coordinate of 13. So that sounds like, if I do just maybe 13 minus 3, it looks like I'm going 10 units from 3 over to 13, right? 10 units. Now, I only want to go 3/5 of that. So now I'll say 3/5 of, which would mean multiplying, 3/5 of 10 is going to be 30 over 5, which is 6 units. So I actually want to go 6 units over from 3. So 3 plus 6 would give me 9. So my point is going to be at 9 comma something, right? So my answer is going to be 9 comma something. Now I just need to find what that y coordinate would be. So my vertical movement from A to B takes me from -4 all the way up to 11. So what is that distance from -4 to 11? Well, I'm going to take the larger number and I'm going to subtract the smaller number, so 11 minus -4, and that's going to give me 15. There's 15 units to go from -4 up to 11. And now I want to take 3/5 of that distance. I want to move 3/5 of the way from -4 to 11. So I'll take 3/5 times 15, which is going to be 45 over 5, which would be 9 units. So now I need to move up. I need to move up 9 units from -4. So that would be -4 plus 9 would give me a y coordinate of 5. So it looks like 9 comma 5 is about 3/5 of the way. So let's just check that. Where would 9 comma 5 put me? It looks like on this graph each block is worth 2. So from 8 I need to go half a block to get to 9. And then here's 4, another half a block would put me about there. And yeah, that seems to make sense. It's a little over halfway from A to B. Now the next concept that we're going to take a look at is called the distance formula. And the distance formula allows us to figure out, well, how far is it from P to Q? Not where's the midpoint at, but just how far is it from P to Q? And this formula looks a little intimidating as well. It's the square root of the x coordinate subtracted and then squared plus the y coordinate subtracted and then squared. This is really actually related to the Pythagorean theorem. If you remember the Pythagorean theorem from middle school, it's something we can use to find the hypotenuse length on a right triangle. So a right triangle has a 90-degree angle in the corner, and then the hypotenuse is that longest side right there. And we would do a squared plus b squared equals c squared to find that. But in this case, on this coordinate plane, this distance right here that we call a would simply be the 2 minus -4, which would be 6. It would be 6 units along that. And that 2 minus -4 is this guy right here, x2 minus x1. For the b distance, it would be 1 minus -3, which is 4. And if you remember the Pythagorean theorem, it says that a squared plus b squared equals c squared. Well, the a distance that we got is 6, right? That was the two x coordinates subtracted, so 6 squared plus the b distance, which would be 4, would equal this distance right here, c squared. So now if we clean this up using our order of operations, we would have 36 plus 16 equals c squared. So that would be 52 equals c squared. And c would be the square root of 52, which is about 7.21 if we type it in on our calculator. And we can see that's the answer they gave us right there. So this looks intimidating, but really all it is it's the Pythagorean theorem. A squared plus b squared equals c squared. I want to find the distance horizontally that I need to move from point P to point Q, and the distance I need to move vertically from P to Q. And then that is going to be my A and my B, and I plug it into the Pythagorean theorem. Take the square root here at the end. Don't forget that when we have a variable squared equals a number, we need to do the square root, not divide by 2, and that'll give us our final distance. So let's take a quick look at one more problem. I'm going to start this problem for you and then probably let you look at how it would be finished. It says a pitcher throws a ball to a batter who hits the ball to the shortstop. If the ball travels in a straight line between each, what is the total distance traveled by the ball? Round your answer to the nearest tenth of a foot. So we need to figure out how far this distance is here, pitcher to batter, and then we're going to find out how far this distance here, batter to shortstop, is, and we're going to add those together. So we'll call this distance 1, and we'll call this distance 2, and our final answer is going to be distance 1 plus distance 2, right? This is what we need to do for a final answer. I'll go ahead and get you started finding distance 1, and then I'll let you find distance 2. So distance 1 is this distance, and so we need to look at what is this length right here and this length right here. So this length looks like it's 1, 2, 3, 4, 5 blocks, but each block is worth 1, so that's going to be 5 units, and up 5 units. So distance 1 squared, I'll write it this way, distance 1 squared is equal to 5 squared plus 5 squared. And that would be distance 1 squared would be equal to 25 plus 25. So distance 1 squared is equal to 50. And that means distance 1 is equal to the square root of 50. And let's see here real quick. I gotta grab my calculator and do the square root of 50. Give me a second. So the square root of 50 then would be about 7.1. That's 7.1 units, and each unit is 9 feet. So the distance 1 would be 7.1 times 9, which is going to be about 63.9 feet. And that's just this distance 1. Now what you'll need to do is find distance 2 using these 2 points. Same idea that we did here. And then add those two together.